Hello, everyone. I'm Hardik from LearnWeb3 and super excited today. We have Antonio from Matter Labs. He's the developer relations engineer at Matter Labs, just the company behind zkSync and zkSync Era, to talk about abstraction, account abstraction on zkSync. So this is kind of part two of the series of zkSync workshops we've been doing. The last one was talking about, an intro to zkSync and how to bridge a contract from Ethereum and deploy it to zkSync. Today we're going to talk about account abstraction. So I'm super excited. If you haven't seen the first workshop, I'm going to put a YouTube link in the chat to go watch the recording afterwards. This one is also being recorded. So if you're just trickling in, or you have to head out in the middle for something, don't worry about it. This one is also going to go up on YouTube and you can always catch up over there. But yeah, with that, I'm super excited for this. Antonio, over to you.
Yeah, thank you. Thanks for having me. Yeah, as you said, we did last week the introduction to zkSync. So if you haven't watched that workshop, really recommend going through that one because this one is a little bit more technical, a little bit more advanced. But if you have no idea what is account abstraction, you've heard the words, but you don't know what it is, you don't know what are paymasters, you're in the right place because this is like an introduction for account abstraction and for paymasters. So I will make it as beginner friendly as possible. So yeah, today we're going to talk about smart contract accounts and paymasters, and I will show you how to actually create smart contract accounts and paymasters on zkSync. Okay, so about myself, my name is Antonio, and I'm a developer relations engineer at Matter Labs. Basically, my job is to help projects build on zkSync and also to educate developers about the different features of zkSync and all the tools that we provide. That's SDKs, plugins, etc. Apart from that, I have this blog that I started when I was learning Solidity a couple of years ago. It's called Solidity Tips. And that's also my Twitter profile in case you want to follow me there. So, yeah. And this is the agenda for the workshop. It will be around 35, 40 minutes, depends if we have a lot of questions coming in. So we will start with a quick overview of zkSync. Yeah, just a reminder of what we talked in the previous workshop. Then we're going to talk about accounts on Ethereum, how they work, and the problems that they cause because of the way they were created. Then we're going to talk about what is account abstraction and what is EIP 4337, which is the improvement in the proposal to implement account abstraction on Ethereum. And finally, we're going to see how we implemented account abstraction on zkSync and how to create smart contract accounts and paymasters. So at Matter Labs, our mission is to accelerate the mass adoption of public blockchains because we think that will break financial barriers and enhance the world freedom. And obviously, Ethereum is the largest public blockchain by many different metrics. And our job during the last couple of years has been focused on improving its scalability with zkSync. A couple of years ago, we launched zkSync Lite, which was a protocol to do payments and token swaps. And still today, it's used by a lot of projects like Gitcoin, and it makes transactions of Ether and token swaps super, super cheap. With Zik, we've also built zkSync Era, which we launched almost a month ago. And for those that you don't know, it's a general purpose layer 2 rollup that scales Ethereum with zero knowledge tech. And it's powered by zkEVM, and it has native account abstraction. zkSync Lite, the previous version that we launched, it was limited to payments and token swaps. As I said, zkSync Era, it's a full-blown general purpose. You can deploy any smart contracts that you want. So the possibilities are endless. You can build games, tokens, NFTs, whatever you can think of. Just a quick overview of zkSync and rollups in general. They increase the scalability of the layer 1 network, which is Ethereum, by moving the execution of the transactions off-chain of the layer 1 into the layer 2s. And it also reduces transaction fees by bundling transactions together into batches and splitting the fees between all the transactions of the batch. And they also maintain the same security guarantees as the layer 1 because we post all the transactions data into Ethereum. And we know that in order to bring mass adoption, which is the mission of our company, we need teams building amazing projects. And that's why one of the main goals of zkSync was to maintain the same developer experience by supporting both Solidity and Viper, which are the most used programming languages for smart contracts, and developer tools like Hardhat. You can use Hardhat to develop on zkSync era. On top of that, zkSync is powered by our zk EVM, which is not only compatible with Ethereum's virtual machine, but also extends its features. And we can say it's like an EVM plus because we have, apart from all the features of Ethereum, we have account abstraction, paymasters, L1 to communications, and is extensible. Now, to understand how account abstraction can improve the user experience, we need to review the current problems that we have with the user experience in Web3. And to understand those problems, we need to know about the different types of accounts on Ethereum and how they work. So brace yourselves. On accounts, on Ethereum, we have two types of accounts. We have externally owned accounts, and we have smart contract accounts. Externally owned accounts are like normal user accounts. If you have used your MetaMask is an externally owned account, or Trust Wallet, or your Ledger is the accounts that 90% of people use. These accounts have an address, nonce, which is like the counter of your transactions, like it counts the name of transactions that you have done, and a balance. And every externally owned account is associated with a signer, which is made of a public and a private key. We all know that the private key is what we use to sign transactions. So given a message or a transaction signed with the private key, the network can verify that only the owner of that account who has the private key signed it. And how are accounts linked with signers is with the account address. The address of the account is the last 20 bytes of the hash of the public key. So this is how the account and the signer are linked together. On the other hand, we have smart contract accounts. They have an address, a nonce, a balance, but they also have a code, because the code that you deploy when you deploy a smart contract, yeah, that's the code of the smart contract account. And yeah, every smart contract is an account because you can transfer keys to it. So we have these two types of accounts. The important thing here is that only externally owned accounts can initiate transactions. Basically, if you deposit some ETH into a smart contract, the only way to withdraw it is for that smart contract to have a withdraw method and to initiate a transaction from an externally owned account to withdraw to call that method. So smart contract accounts, they cannot initiate transactions. That's pretty important. Now, this differentiation of these two types of accounts and how they work generates a few problems. First, if you lose your private key, which is, again, part of your signer, you lose your account. And if you find the private key for whatever reason, you own the account. So, because the two parts are coupled together. So basically, they are not the same, but you can say that both the account and the signer, they are the same, because if you have one, you have the other. And this is a problem because keeping a private key safe is not easy at all. People are used to have their passwords written down in a POSIT on their desks, and they forget the passwords all the time. So this is not sustainable to onboard millions of users because nobody knows what to do with a private key. And also, there is no way to recover a private key. If you lose it, you lose your account, it's gone. There is no recovery methods. There is nothing you can do about it. And on top of that, the logic to verify transactions from externally owned accounts, it's hard-coded in the EVM, and there is no way to change it. So externally owned accounts, they will always use the same verification logic. So in summary, user experience is not great right now. Now, solving these problems is the main goal of account abstraction. But how do we do it? Well, instead of using accounts that are linked to a signer, which logic is hard-coded in the EVM, we'll break this relationship and we will use smart contract accounts. And to replace the signer, these accounts will implement its own logic to verify transactions on the smart contract. So the logic that is hard-coded in the EVM for the signers, we will put that logic in the smart contract account. So yeah, in summary, we will just move to use the smart contract accounts. And these are the problems and the differences between externally owned accounts and user smart contract accounts. So again, we will not have this signer anymore because we will move this verification logic to the smart contract. For private keys, we can use alternative methods to sign transactions. So for example, we can use biometrics or authenticators, anything we can think of. And for recovery, externally owned accounts, they have no recovery. With the smart contract accounts, we can implement any recovery methods in the smart contract account. We can have social recovery, we can have backup keys, we can have guardians, which can be other accounts that can recover the account for you. So having a smart contract for an account opens the door for all these possibilities because they are fully programmable. So some of the features that we can implement, again, we can have different signature schemes. Ethereum uses ECPSA by default, and this is hard-coded in the EVM. We can use any other algorithm to send transactions. We can have native multi-sig accounts. We can have accounts with spending limits or application-specific accounts. Imagine that you have a smart contract account and you only allow it to interact with the smart contracts from OpenSea. So that would be like your NFT account. And if someone tries to take the account and go to Uniswap and do something with it, it won't work because the account is hard-coded. It has some logic to only interact with the smart contracts from OpenSea, something like that. You can have social recovery, as I said before. And again, smart contract accounts, they are smart contracts, they are fully programmable. So yeah, you can add any features you can think of. Another thing you can do is multi-call transactions. So instead of doing the approve and then send for ERC20 tokens, you can bundle all transactions in a single one and send them all together. I mean, yeah, multiple possibilities here. But there is one problem. As I said before, only externally owned accounts can initiate transactions. So if we all start using these new smart contract accounts, how are these accounts going to initiate transactions? Because they cannot do it. And the solution to this is what EIP 4337 tries to solve, which is implementing account abstraction with an alternative mempool. And I'm going to explain what EIP 4337 is, which is a little complex because it introduces a lot of new concepts. So yeah, let's go through that. First, we have the concept of user operations. These are like the transactions that are submitted by smart contract accounts. They are called user operations instead of transactions because they describe a transaction that will be sent on behalf of the user. But to simplify things, you can think of user operations as transactions from smart contract accounts. Then these smart contract accounts send these new user operations to a dedicated mempool instead of the same mempool that externally owned account use. And this is very important to understand how everything works. So they send these new transactions to a completely new mempool. In addition, we have the concept of bundlers, which are nodes running a specific code. And these new nodes, they listen to the new mempool and package multiple user operations together into a single call to a new smart contract that is called the entry point contract. So we have smart contract accounts sending a new type of transactions to a new mempool, and then we have a new type of nodes picking transactions from this mempool and sending them to a smart contract that is called the entry point. And the entry point contract, you can think of it as an Ethereum system contract. And once it receives these transactions or these user operations, it verifies them and executes them. So in summary, EIP 4337 proposes creating a completely new transaction flow for smart contract accounts. And I know this is like a lot of information to digest, so let me show you how it looks like. Here we have it. So on top, we have the transaction flow for externally owned accounts, like the accounts that we all know that most of you use, like your MetaMask or Trust Wallet. And when you send a transaction, it goes to the mempool. And then we have nodes and validators picking transactions from this mempool and adding them to the blockchain. With EIP 4337, what we will have is a new type of accounts that are smart contract accounts sending transactions to a new mempool, which is called the user operations mempool. And then we will have a new type of node, which is called the bundler, taking these transactions from this new mempool, sending them to the entry point contract, and the entry point contract will verify them, execute them, and add the transactions to the block. So I know it's a lot of info. I don't know if we might have some questions up until now.
Yeah, we have a couple of questions. So, number one, you were talking about smart contracts accounts having the advantage of using a signature scheme other than ECDSA.
Yep.
So, one question is like, what is the benefit of doing that? Is that primarily to support like more zk compatible schemes, or like is that a quantum resistance thing, or why would you
Yeah.
do
So
that?
yeah, there is a lot of people talking about quantum resistance. So you can use algorithms that are more future-proof, you can say. But another thing you can do is use the same algorithms that your iPhone uses. So you can use your Face ID to sign transactions and verify them on the smart contract account, or or for your fingerprint. If you have a Mac with a fingerprint or a Windows laptop that have fingerprint, there are a lot as well. They use a specific algorithm for that fingerprint, so you can use that to sign and verify transactions. So it opens the door for all these new use cases.
Amazing. That's, yeah, I didn't think about it like that. That's awesome. um Next question is that we have, and maybe you'll cover this later, but um how does wallet recovery actually work in smart contract accounts?
It's not that it works in a specific way. It's just that you have the possibility to enable it however you want. Uh, you can have, I mean, when I think about social recovery, you probably can think of having some kind of centralized service that sends you an email and does something, and then it updates the account somehow. But the good thing is that smart contract accounts are fully programmable, so you can implement it however you want. A lot of recovery mechanisms out there, they rely on guardians, which are like other wallets that have permissions on your account. And you can do things like, okay, if my account has been inactive for 2 weeks because I lost my keys or the way I have to sign transaction, these other accounts can initiate transactions or can reset the account or do something. So it's just that you have all being a smart contract, you have the possibilities to program any logic that you can think of.
Awesome. Okay. Then we have a couple more questions. So regarding these bundler nodes, what is the incentive for anyone to run a bundler node?
Yeah, that's a pretty good question, and that's something that I asked the Ethereum Foundation when they launched when they launched the EIP 4337. The incentive is that the bundler takes a cut of the transaction fees. So there's an economic incentive there. They receive fees for or part of the fees from all the transactions.
So to my understanding, the bundler has like some native tokens to pay for gas for these user op transactions, and
No,
then
it uses, so when you send transactions, every transaction or every user operation, let's call them by the name, they pay gas fees on ETH as well. So then the bundler, the job of the bundler is like to build blocks of user operations, and they take a cut of all the gas fees from all the transactions. So
I
I
see.
don't know exactly how much that is. I don't know, imagine it's 10% from all the transactions or something like that.
So, but in that case, since like if the end user is using a smart contract account and we need an EOA at some point to initiate the transaction and pay for the gas, like who actually is paying for the gas then?
No, you are actually paying. So your smart contract account has some ETH balance because
Oh, okay.
and then when you send, what you send is, okay, I want my smart contract account to use to interact with this liquidity pool in Uniswap, for example. That's a user operation. It's an intent for your smart contract account to interact with other contract of the network. And that transaction that you want to do, that you intend to do, has some gas fees cost, which is similar to the gas fee to interact with the liquidity pool from your MetaMask account. The bundler will say, okay, you can do that, and if part of the entry point contract, what we'll do is check how much is the gas fee to execute that transaction and send that to the bundler. So you must have, your smart contract account must have enough ETH to interact, to actually execute the transaction.
I see. Okay, that makes sense. Next question is: Does zkSync era is zkSync era's native account abstraction exactly the same implementation as EIP 4337, and are EOAs still a thing on era?
That's a good question, and we will see this in 10 minutes.
Okay. And then last question
But
is: Can
in
anybody run a
summary,
bundler node? Oh, sorry.
yeah. So in summary, our implementation is different. It's a slightly different, and I will go into the details later. Can anybody run a bundler? I know there are node providers, like the same way you can run an RPC node from Alchemy or QuickNode and all these providers, or ChainStack, for example. I know these same providers are running bundlers, and I'm assuming that they are running like an open source code, like Get for an RPC. I assume there is a similar client for bundlers right now, but I'm not 100% sure.
Perfect. Cool. That's all the questions for now. Thank you so much for answering them all.
Okay, so we have talked about the different types of accounts, and we have talked about how EIP 4337 works. I haven't talked about, let me see. I haven't talked about, oh, here it is, Paymasters. So Paymasters were part of the title, and not a lot of people know about Paymasters and what they are. And this is the description from EIP 4337. To summarize, you can say that Paymasters can sponsor transactions for users. That means like paying the transaction fees for users. They allow users to pay fees in ERC20 tokens, which is very important. And they implement a different flow. So when the paymaster is not equal to the zero address, the entry point implements a different flow. That's a tricky question, a tricky phrase to understand. I will explain you with the diagram later on. But yeah, paymasters, they can sponsor transactions for users, and they allow users to pay fees in ERC20 tokens. Those are the two most important things about paymasters. So what features are enabled when you use paymasters? Again, you can pay fees with any token, which is huge because imagine that you're trying to onboard your parents into using blockchain and they know about USDC, or it's easy for them to say, okay, USDC is $1 or UST is $1, and they want to buy something. But if they want to buy something online and that's a transaction, and then well, all of a sudden they need ETH, which they have no idea what it is, that's like a huge barrier for a lot of users. But if you allow users to pay fees with any ERC20 token, they can pay the fees with USDC or UST, and then it is like, okay, this transaction I'm transferring $20 plus the fee is 30 cents or something like that. Okay, everything makes sense. You send it, you pay it, that's it. And you can think about the fee as like the Visa fee or the MasterCard fee. So it's a lot easier to understand. On top of that, when you allow users to pay fees with ERC20 tokens, you are increasing the utility of those ERC20 tokens. Again, another example, imagine if Uniswap decides that for any swaps on the DEX, you have to pay the fees with the Uni token. Then the Uni token from that time over, from then, is not only used for governance, it's also used for for doing swaps in the protocol. So that increases the utility, which should increase the value of the ERC20 token. With paymasters, other things that you can do is you can have a paymaster that pays the gas fees for users that have a specific NFT. This is a good example for DAOs. For example, in order to be a member of a DAO, normally you have to have an NFT. The DAO can build a paymaster that if the user has the NFT, the paymaster will pay the gas fees. So it will be gasless for the members of the DAO. You can do other things like pay the first 10 transactions of every month for the users. And again, basically anything, because paymasters are smart contracts as well, and they are fully programmable. So any logic you can think of, you can put it in the smart contract. And here in the diagram, you can see the paymasters down there. So the way it works is this new user operations, part of the transaction data is the paymaster information. So if the transaction contains some information saying, hey, this transaction has to be processed by a paymaster, the entry point will forward the transaction to the paymaster contract. The paymaster will do its own logic and decides if it will pay the transaction fees or not. Then it will send it back to the entry point contract, and then the entry point will add it to the blockchain. So that's where paymasters are in the EIP 4337. So in summary, again, there is a completely new transaction flow for smart contract accounts. There is some logic for paymasters, and this is EIP 4337. But there is something not so good here. And as you can see, paymasters are only linked to the entry point contract. That means that if you are using an externally owned account, if you are using your MetaMask, your Trust Wallet, your Ledger, you will not be able to interact with a paymaster on Ethereum, which is not great because 90% of people still uses MetaMask. So at this moment is something not so good. So when is account abstraction available? Well, it's actually live. The entry point contract was audited and deployed on mainnet on March 1st. And there are multiple providers offering services to run bundlers and to deploy pre-built paymasters. As I said before, there is Myconomy, Alchemy, there's FSpot, a lot of providers running bundlers. And Again, this implementation on Ethereum is great because we have programmable smart contract accounts, which can offer and improve onboarding for users. And then on smart contract accounts, you can put things like social recovery, new signature methods, and in general, yeah, better user experience. And you have Paymaster for smart contract accounts, which, yeah, it's something new. We will have to migrate to smart contract accounts, but yeah, it's a lot of good things. However, there are things that are not so great. So these changes are not integrated at a protocol level. As we saw, they have built like a new transaction flow on top of the existing one, and there is a separate transaction flow for externally owned accounts and smart contract accounts, and everything is more complex because it requires an additional client for bundlers. We have a new mempool, and also, as we said, paymasters are not available for externally owned accounts, which are 95% of the users. Finally, account abstraction does not improve the transaction fees on Ethereum because it wasn't supposed to do it, but yeah, that's it. So, can devs do something? Can we take EAP 4337 one step further? Well, yes, we can. And before going into this, something looks different probably. We had some problems with the recording, so we are re-recording this part of the presentation. It's the same, just bear with me. We're going to talk about the zkSync era account abstraction implementation. We've made things a little bit different from EAP 4337, and this is how we did it. First, on zkSync, account abstraction implementation is at the protocol level. We built a simplified solution for both users and developers. Smart contract accounts and paymasters are first-class citizens because under the hood, all accounts, even externally owned accounts, behave like smart contract accounts, and all accounts support paymasters, which is huge. We have a single mempool and transaction flow. All accounts follow the same transaction flow, no matter if they are initiated by an externally owned account or a smart contract account. And finally, we have our own version of the bundler and the entry point contract inspired by EAP 4337. Our bundler is called the bootloader, and the entry point contract. Sorry, our bundler is called the operator, and the entry point contract on zkSync is called the bootloader, and it processes transactions from all types of accounts. And this sounds great, but let me show you how it looks. Here it is. As you can see, we have a simplified transaction flow with a unified mempool and our own version of the bundler, which we call the operator, that takes transactions from this mempool and sends them to the entry point contract, which we call the bootloader. And as we have a single transaction flow, both externally owned accounts and smart contract accounts can use paymasters. So awesome. Okay, so we know the EAP 4337. We know how we have implemented account abstraction on zkSync, slightly different, but how do you actually build smart contract accounts and paymasters? Well, this is what we're going to cover next. And before getting into seeing some examples of code, just a quick recap of the developer experience on zkSync. How do you create applications and smart contracts on zkSync? First, you write your contracts with Solidity or Viper. If you already have an application, you're most likely good to go, and you won't need to do any changes in your smart contracts. Next, you need to compile your contracts using our special compilers called zkSolk or zkViper. And we use different compilers because the bytecode that they generate is compatible with our EVM. You can use our SDKs for scripts or front-end integrations. And the good thing is that our SDKs are built on top of the most popular libraries. So, for example, The JavaScript SDK is built on top of ethers, and it uses the same classes and methods. So in most cases, you won't need to do anything, or you just need to change an import. And for example, the Python SDK is built on top of web3.py, and we have SDKs also in Go, Java, and Swift. Then to deploy your contracts, you can use Hardhat Deploy, which is the most popular Hardhat plugin to deploy contracts, or you can use the zkSync deploy special package. That's it. Once your contracts are on the testnet or mainnet, you're good to go. They are running, and you don't have to worry about anything else. So how do you create the smart contract accounts? Well, this is a super huge part of a smart contract account. And don't worry if you cannot see it very well, because I will have a repo at the end that you can check. This is just part of an account. And the smart contract accounts, they implement the iAccount interface that we provide as part of the zkSync contracts package that you can install. And this interface comes with 5 methods. 2 of them are required. So the first one is validate transaction, which obviously takes care of validating the transaction. But in more detail, it increments the nonce of the account. It checks that the account has enough balance to pay for the transaction fees, and it should also verify that the signature is correct and any other validations that you want to add. So this is the first one, validate transaction. The second one is execute transaction, that takes care of forwarding the transaction to the destination contract and passing any value or transaction parameters. And here, for example, you can see the validate transaction method. It uses the non-shoulder system contract to increment the nonce. It also checks that the account has enough balance to pay for the gas fees and the value of the account. And then it's using here an additional method called isValid signature to validate the signature of the account. And again, the full code of this account will be in a repo that I will be sharing. So these are the 2 required methods that you need: validate transactions and execute transaction. But there are another 3 optional methods. We have pay for transaction, which pays the transaction fee to the bootloader, and it uses the helper method pay to the bootloader method. So you just have to call that one. Then we have prepare for paymaster, which processes the paymaster parameters. And again, there is a helper method for that in the transaction object that it receives, that is called process paymaster input. And then finally, we have execute transaction from outside, which is used to execute transactions by other entities. As we saw earlier, the bootloader contract is the one that will actually send the transaction to the smart contract account. If we want any other entity to actually send transactions to our account and we want to process them and accept them, we will have to enable that in this method, execute transaction from outside. And so this is a smart contract that you will need to create to have your smart contract account. And obviously, you can extend all these methods to implement any feature of the ones that we mentioned before, like recoveries, additional validation, additional signatures. So you can extend this contract and put any logic that you want. Then once you have your smart contract account, you can create a factory contract to deploy it, which is something that wallets like Argent do, because they deploy thousands of instances of these smart contract accounts. And the factory will have the bytecode of the smart contract account with the deploy account method that you can see here, and it will deploy that bytecode by calling the create to account method of the deployer system template. So Here you can see that this factory only has this deploy account, and what it does is the deploy system contract calls this create to account, and here is passing the bytecode of the smart contract account from the previous slide, for example, and the parameters for the constructor. In this case, it has an owner address, and this will be used to deploy new instances of the smart contract account. And again, these are just like very high level contracts. An example, I will have a repo at the end, and we have tutorials in our docs that you can follow to actually go step by step and create your own smart contract accounts. So for smart contract accounts, we just need accounts that implement the iAccount interface with two of the two required methods that are validate transaction and execute transaction. What about paymasters? Well, for paymasters, again, paymasters are as well smart contracts, and they take care of deciding if they will pay the transaction fees for the user or not. And again, for paymasters, we also have an interface. In this case, it's called iPaymaster, which contains two methods: validate and pay for paymaster transaction, and post-transaction. And post-transaction is optional. So validate and pay for paymaster transaction is pretty self-explanatory. It will do any validations that we want and execute the transaction by sending the fees to the bootloader contract. The post-transaction, as I said, is optional, and you can use it to make an event that you can capture in your front end or in any monitoring script that you have. Is totally up to you. Then zkSync provides two built-in paymaster flows. They are called approval-based and general. So the general is for anything. It's like general. And the approval-based is the important one, because it's the one that is used for ERC20 tokens. And if you have used ERC20s before, you know that normally you need to do, like, whenever you're going to spend them, you need to first approve and then accept the spending, which is like two different transactions. And if we were to allow a user to pay ERC20 tokens for gas fees, he will need to first approve that we spend those ERC20s, and then we will accept them. So that will require two transactions as well, which is not ideal. So if your paymaster implements the approval-based flow, it will do the approval behind the scenes. So for the user, it will be just sending a single transaction, and yeah, we will take the specific amount of ERC20 tokens from the account, and for him, it will be just sending a single transaction, and yeah, everything will work out of the box. So again, in the validate and pay for paymaster transaction, we can put any validation that we want. We mentioned, like, for example, paying fees for users that have a specific NFT or things like that. You will put that logic in this method, in validate and pay for paymaster transaction. Then once we have our paymaster smart contract, we need to deploy it and we need to fund it, because obviously the paymaster is actually going to pay the gas fees with ETH, and he's going to send that amount to the bootloader system contract. So we need our paymaster to actually have ETH. Then when it comes to actually interacting with the paymaster, we have to add additional parameters to the transactions, and these are the paymaster address and the flow, which again is general approval based for ERC20s. And we also have the inner input, which is a payload that we want to pass to the paymaster. Imagine that our paymaster is password protected, and we want that the paymaster will pay the gas fees for the users that know the password. We will send the password here in the inner input, for example. And to encode the paymaster params, we will use the zkSync Web3 library that has this get paymaster params method. And here we just pass again the paymaster address, the type of flow, and any input that we want to pass. And finally, we will pass these parameters as transaction overrides. Here, imagine that we have a contract with a method and some parameters, and then at the end, we will add this object with custom data, and inside that custom data, we will have the paymaster params and the gas per pack data, which is like a fixed value that help us with the cost of publishing data to everyone. So that's what we need. For paymasters, again, a smart contract that implements two methods from the iPaymaster interface, and we'll need to deploy it, fund it, and then to interact with it, we need to just pass a few parameters in the transaction. So, main takeaways in general, zkSync is a layer 2 rollup that scales Ethereum and is powered by a zkVM. It implements account abstraction at the protocol level. Account abstraction improves the user experience, which will increase the adoption. Smart contract accounts and paymasters are great. They enable this bunch of new features that will bring a lot of users. And yeah, at the end of the day, possibilities are endless. Both smart contract accounts and paymasters, they are smart contracts, and you can implement any logic in them. Here are next steps. If you want to learn more about account abstraction, check out this series of articles from Argent. Argent, they've been talking about account abstraction for many years now, and they have wallets for zkSync, also for Stacknet. And yeah, they are like probably the team that has been working more in account abstraction. So they have a 3-part series of articles. Then we have this repo that I created with just some templates, so you can review some examples or starting points to create the smart contract accounts and paymasters. But we also have 2 tutorials in our docs. One to create your own paymaster that accepts ERC20 tokens in exchange for the gas fees. So basically, it allows users to pay gas fees with an ERC20. And then another one to create a native smart contract account that is multi-sig. So it requires signatures for 2 different users. And then we have our docs, our Discord, and our Twitter account. And here's the QR code that I mentioned with links to the slides, to the slides, to my Twitter profile, and to all the tutorials and everything. So yeah, here you have all the info. I hope you enjoy it. And yeah, that was it.
Amazing. Thank you so much, Antonio. Just a couple questions I'll re-ask from the original recording because I think those were useful.
Okay.
You were talking about bundlers, right? So the question was, can anyone run a bundler, first of all? And what is the incentive to be running a bundler today?
Yeah, so bundlers are, the incentive to run a bundler is that they take a cut of the transaction fees. So yeah, it's the same as running a miner that back in the days, they were getting some fees. For a bundler as well, you are basically creating batches of transactions and sending them to the entry point contract. So you are actually doing some job to secure the network, and you get rewarded for that. So yeah, the incentive is a cut of the transaction fees.
That makes sense. And also for these smart accounts and paymaster interfaces that you were showing, are these like sample implementations or the canonical implementation, or is it that like every wallet usually implements their own version of it based on how they want to do things?
So these are the methods that your accounts and paymasters have to follow. So they have to implement these required methods for the smart contract accounts. They were validate. Sorry, I never remember the full names. For accounts, it was validate transaction and execute transaction, and for paymaster is validate and pay for paymaster transaction. So basically, what you need is your smart contract account or your paymaster. They will have to have these methods with the same signature for the method. That is same method name, same parameters, same return type. But then inside these methods, you can put whatever logic you want. So in validate transaction, you can do any validations that you want. If you have an account that accepts the ECBSA signatures, you will have to validate that signature. If you are using the biometrics for your account, obviously you will have a different signature verification. So it's that your smart contracts have to follow these rules that have these methods, but then the implementation that you do of those methods is up to you.
Amazing. Okay, that makes sense. But yeah, I love it. I said this before, I'll say this again. This whole workshop makes me want to go out and build a zkSync mobile wallet so I can write these contracts and play with these contracts. Absolutely amazing, dude. I loved learning everything about it, and thank you for doing this. Thank you for doing this for the second time now. Really, really appreciate it. And
yeah, and before we finish again today, I'm not sure if we mentioned it the other day at which point of the workshop we did it, but we're going to have a bunch of hackathons online and in present conferences, and account abstraction is always one of our bounties. So because we just want people to build and experiment with these smart contract accounts and with paymasters. So just follow us on Twitter and join our Discord. We will be running a bunch of hackathons. So if you wanna, play with them and maybe win one of the bounties, make sure to stay in touch, to stay up to date, and we will be happy to have more people building on this implementation of account abstraction.
Absolutely, 100%, guys. The job market is iffy right now, so we might as well take part in hackathons. Level up for the next time jobs are back to normal. Win some prizes, build some cool shit, get your name out there. So highly recommend looking at their Discord, going through their website, and joining these hackathons if you can. And with that, Antonio, do you have anything else to add?
No, that's it. You can follow me on Twitter if you have any questions. And just build on zkSync. And the more projects we have, the more I think the end goal of account abstraction is to improve the user experience. So if you think that, we know that today the user experience in Web3 it's very bad. It's for super advanced users. And the way I think about it is like, how will my parents use crypto in general? And all the pieces that are missing are things that are potential projects that you can build. So I encourage everyone to build those missing pieces.
Absolutely. That's an amazing analogy, actually. How would your parents think about it? I can't imagine them trying to save their private key somewhere securely. So that's actually an amazing analogy. So keep that in mind, guys. Think about that when you're building stuff at hackathons, and think about how you can make the user experience really simple. And with that, thank you everybody. Thank you everybody for coming. Thank you everybody who's watching the video now. Thank you so much, Antonio, for doing this. And appreciate all of you. Have a great rest of your day.
Thank you.